The next video in the mole unit is titled The Molar Mass of Elements. You can see there are two learning targets here. We want to be able to define molar mass and calculate the molar mass of compounds. And we also want to use molar mass to convert between moles and mass of a substance. Some resources here you might want to check out. The textbook you can see is section 10.2, and then some videos and some practice stuff that if you want to link to them would be fantastic. Alright, so we have learned already that a mole is a counting unit, just like a dozen or a ream or a pear is. So just as an example, if I have a dozen oranges, 1 dozen oranges, that would be 12 oranges, as we know, because 12 means a dozen. And let's say I had 1 dozen pears. That would be 12 pears. Now the question I have, would the mass of these 12 oranges, would that be equal to the mass of the 12 pears? And of course the answer to that is no. Because oranges and pears, they don't have the same mass. Oranges are more massive than pears. At least an average size orange, I would say, is more massive than a pear. So they wouldn't have the same mass. So we can apply that same thinking to moles. If I have a mole of 2 different elements, I'm going to have the same number of atoms of each. 1 mole of copper, let's say, and that would be 6.022 times 10 to the 23rd atoms of copper. And I have, let's say, 1 mole of cobalt. That would be 6.022 times 10 to the 23rd atoms of cobalt. But that doesn't mean the masses are going to be the same. The mass of a mole of copper does not equal the mass of a mole of cobalt. They would be different because they're made of different things, just like oranges and pears are made of different things. So the question becomes then, how do we determine what the mass is? How would I know what the mass of a mole of copper is or cobalt? Well, that comes from what we call the molar mass. Here's a definition for you. The molar mass is simply the mass of 1 mole of a substance. Mass of 1 mole of a substance. And this is very convenient to look up for elements because the atomic mass of an element is equal to, at least numerically, the molar mass in grams per mole. So let me give you an example of what that would mean. We said earlier that the mass of 1 mole of copper does not equal the mass of 1 mole of cobalt. Well, that's because if you look at the periodic table, just take a look at the periodic table, let's find copper. The atomic mass of copper is 63.55. What that means then is 1 mole of copper has a mass of 63.55 grams. I'll just jot that down here. 1 mole of copper equals 63.55 grams of copper. And likewise, I can see that 1 mole of cobalt, if I go back to the periodic table here, 1 mole of cobalt is 58.93 grams. Equals 58.93 grams of cobalt. So we can see here that the atomic mass is different for every element. So every element has a different molar mass. The reason why it works this way as far as the atomic mass equaling the molar mass, if you remember how the mole was defined relative to carbon-12, as was the atomic mass unit, that's why it works this way. Alright, so what we want to do then is we want to be able to take this idea here of being able to look up molar masses on the periodic table, and we want to use those as conversion factors. So let's look at this first example problem here. We're asked, a lab procedure calls for 3.00 moles of carbon. What mass of carbon will you need? When we're asked for a mass, the unit for that will most likely be grams. So I'm going to ask how many grams of carbon are equal to 3.00 moles of carbon. Well, what we need here is a relationship between grams and moles. That comes from the molar mass. If you look at your periodic table, you will see that 1 mole of carbon has a mass of 12.01 grams of carbon. Just pull that back up here. Here's carbon on your periodic table. You can see the mass, the atomic mass listed is 12.01. So 1 mole of carbon would have a mass of 12.01 grams. So moles of carbon cancel, and all I need to do is plug this into my calculator. 3 times 12.01. My calculator is going to tell me 36.03, but I only get 3 sig figs. This is 3.00 is 3 sig figs. This is 36.0 grams of carbon. One reason we need to be able to determine the mass of a certain number of moles of an element or a compound, that'll be the next video, is simply because we don't have measuring devices that can measure out moles. If you're going to measure out something, say in the lab, we don't have mole counters. We don't have things that can count that many tiny particles. So what we have to do is we have to measure out a mass. We could certainly measure out 36 grams of carbon just using a balance. So that's how we'd have to do that. If we're asked to measure out 3 moles, well, we'd have to convert that to grams, and then that's what we would measure out. So that's why we have to do that. All right, next question. How many moles of barium are present in 59.08 grams of barium? So this is just the opposite question that we were asked. We're looking for how many moles of barium, and we're given a mass of 59.08 grams of barium. And again, I need a molar mass conversion factor, so if I go to my periodic table, I can see the molar mass of barium is 137.33. So that is the conversion factor I want to use. Notice this time, though, that value, the molar mass, is going to go in the denominator because I need to cancel the mass units. So 1 mole of barium has a mass of 137.33 grams. We can plug this into our calculator. We have 59.08 divided by 137.33. And you can see the calculator tells you 0.4302, 0.430204. As far as sig figs are concerned, looks like we get 4 sig figs from the mass. So this is 0.4302 moles of barium. Note about sig figs and molar masses, they are measured. So for example, this 137.33 grams per mole for barium, that is 5 sig figs, so that could limit us potentially. Now, usually they won't, because usually they're either at least 4 sig figs, if not more. So it could limit us, but not if I have fewer sig figs somewhere else. Alright, next question. Determine the number of atoms in 50 grams of tin. So a little bit different here. How many atoms of tin are equal to 50.0 grams of tin? Unless you know the mass in grams of a single atom, you can't do this in one conversion factor. What we're going to do here is we're going to use the same sort of conversion factor we used above, going from grams to moles. If you look at your periodic table, you can see the molar mass of tin is 118.71. So I can use that as a conversion factor. 1 mole of tin has a mass of 118.71 grams of tin. Grams cancel. And then I know that a mole of tin would contain 6.022 times 10 to the 23rd atoms of tin, because that's how many of anything are in a mole. And we've done the problem. Now plugging this into our calculator, we have 50 divided by 118.71 times 6.022 times 10 to the 23rd. And let's see, looks like we're going to get 3 sig figs. So I get 2.5364 times 10 to the 23rd. Rounding that to 3 sig figs, it would be 2.54 times 10 to the 23rd atoms of tin. And there's that answer. Alright, this really is the basics as far as using molar mass as a conversion factor. What is the rest of the video here is some practice problems. So I would just encourage you to pause the video, try the practice problems on your own, and then continue with the video to see how you did. Alright, first practice problem. We are asked, what is the mass of 0.35 moles of krypton? So mass, unless you're asked for a specific mass unit, you could just do it in grams. That's usually the most convenient. So how many grams of krypton are 0.35 moles of krypton? So all we need here is the molar mass of krypton from the periodic table. You can see krypton is 83.80. So 1 mole of krypton has a mass of 83.80 grams of krypton. Moles of krypton cancel. That will just be 2 sig figs. The 0.35 will limit us. So 0.35 times 83.8. That's going to be 29 grams when we round that to 2 sig figs. 29 grams of krypton. Alright, next question. What is the mass in kilograms? So here we're asked specifically for kilograms. So how many kilograms of 8.9 times 10 to the 25th gold atoms? So how many kilograms of gold are equal to 8.9 times 10 to the 25th atoms of gold? Because we're given a number of particles, we need to convert to moles first, because the mass relationship we have is always between mass and moles. So I need to convert this to moles first. So I need to use Avogadro's number, 6.022 times 10 to the 23rd atoms of gold in every mole of gold. From here you can look at the periodic table and find the molar mass of gold. You'll see it's 196.97. So using that, I know that 1 mole of gold has a mass of 196.97 grams. Even though we're asked for the answer in kilograms, the molar mass is still grams per mole. Now I just need to convert to kilograms. There are 1,000 grams of gold in every kilogram of gold. So grams cancel. We've done the problem. Just a matter of plugging in our calculator. So 8.9 times 10 to the 25th divided by 6.022 times 10 to the 23rd times 196.97 divided by 1,000. And it looks like we're going to get 2 sig figs, because that original number of atoms is just 2 sig figs. I get 29 kilograms of gold. Alright, last one. Determine the number of moles of vanadium in 1.25 milligrams of vanadium. So how many moles of vanadium equals 1.25 milligrams of vanadium? Like we just said above, the molar mass is always grams per mole, so I'll probably want to convert this to grams. There would be 1,000 milligrams of vanadium in every gram of vanadium, because milli is 1,000th, or 10 to the negative third. Now I can use the molar mass of vanadium. You'll see that it is 50.94. So 50.94 grams of vanadium per mole of vanadium. Grams cancel. Now we just plug it into our calculator. Looks like we're going to get 3 sig figs. I get 2.45 times 10 to the negative 5th moles of vanadium. The next video we'll look at how we deal with molar mass for compounds, not just for elements. Many of you might be able to kind of decipher that already, but that'll be the topic of our next video.